Yeah, like how lucky are we that the Antarctic ice sheet and Greenland ice sheet are recording climate information for us? Like we'd be flying blind if we didn't have this.
Hello! Thank you so much for checking out Earth Care. Today we're heading to Minnesota to meet Dr. Peter Neff, or Icy Pete, as you might know him from social media. University professor Dr. Peter Neff is a glaciologist and earth scientist and has spent a lot of time studying and working in Antarctica. This is so cool. He's going to be joining Earth Care to talk to us about what those ice samples that they're studying in Antarctica, what they can tell us about climate change, and how what they're discovering impacts us all. Dr. Peter Neff, it is such a pleasure to have you on Earth Care. I can't tell you how excited I've been about this interview. I was already overjoyed. And then I read that you're one of just a few hundred ice core scientists in the world. So truly, what a treat this is.
Thanks. Yeah, no, it's good to chat. I always enjoy sharing this random stuff that we do with people.
Well, random, but my goodness, so important. So you're in Minnesota right now, but as we have watched you on your social media, you were in Antarctica. Let's just start there. What were you doing in Antarctica?
Yeah, so I've been to Antarctica four separate times on the ground, I suppose. I've been on an airborne mission as well. And when we go for sort of 2 to 3 months. And I've always been on ice core projects where we're drilling samples of snow and ice going from the surface of today's snow back in time. I focus sort of on the last couple hundred years, actually, where we have like really high resolution information year to year, season to season. But if you drill deep, and I've been on some of the deep ice core projects where we're drilling down 2 miles deep, right where the bedrock is in Antarctica, and you're talking anywhere from 50,000 years old to 800,000 years old is the longest continuous ice core from the surface to the bottom, 800,000 years, all stacked in that deck of cards. It's sort of like an encyclopedia, right? The top is the most recent volume of the encyclopedia, and the bottom of the ice sheet is volume one, whatever the oldest ice that's preserved is. Yeah, so we ask a lot of different questions when we go. So, and the last time I went to Antarctica was the summer down there, 2018, 2019, on a joint US-Australian project. So we were operating with sort of US funding and some logistical support through the Australian logistical system, going to a special site that they have, just happens to be near where one of their research stations is. That is sort of our best record of atmospheric greenhouse gases over the last couple thousand years. It snows a lot there, which means it captures gases at really, really high resolution. Yeah, so that's the last thing I did. I ran a project where we had sort of between 5 and 15 people at a camp. We were 90 miles from the nearest station. We drove out there with tractors, and we were there for about 80 days drilling ice cores and actually sampling the ice cores there at that site in a really weird way. So that's the last thing I did in Antarctica.
Where do you even start with something like that? I mean,
Yeah.
there's so much to dive into here. We do have a short amount of time, unfortunately, because I feel like this could be a week-long conversation. But so you pull out these ice cores. What exactly are you looking for? You did mention in the snow that is falling right now, you can capture greenhouse gas emissions. So what exactly are you looking for in this sample?
The most special thing about ice cores, and about Antarctic snow particularly, is that it traps samples of the old atmosphere, and it's like a deceptively simple process. Like if you're walking out in Toronto in the snow, you know that you can jump on a pile of snow and it's going to squish down and be sort of soft when it's fresh. And that's because, I can't remember the percentage there, but it's going to be really low density snow, and so there's a lot of airspace between all of the fingers of those snowflakes, right? A beautiful six-sided snowflake. There's a lot of airspace when they all stack together in a pile. And yeah, like in Canada, it all melts away in the summertime, but in Antarctica, it never melts. So you have a massive stack of those snowflakes, and eventually, when you get to a 50-meter pile of snow and then a 100-meter pile of snow, I mean, this is how ice sheets are built. But that amount of snow is heavy enough that it compresses that airspace between the fingers of snowflakes into an air bubble. And I can show you what that looks like. So that's an ice core sample about the size that we tend to drill. And each of those air bubbles started as that air between the fingers of snowflakes. It's a direct sample of the old atmosphere from today back 800,000 years currently. And the biggest push in Antarctic research right now is to extend that to 1 million years or 1.5 million years to get back to some interesting different climate processes. So that's what is just amazing. And that's what we go back to sites where we can get more of those old air samples. And as we get new techniques and have new ideas of what little atmospheric gas we need to study to understand, the future of global warming, we can pinpoint all of those things. So we did a sort of, focused on one wacky little part of the atmosphere when we went back to La Dome, Antarctica, the last time I was there.
Wow. How cool is that? Did you like winter before you got into this?
I grew up in the Pacific Northwest of the U.S., so Washington State, where we definitely had snow in the winter, but it didn't stick around. It's sort of temperate rainforest where I grew up, and but there were always volcanoes in the distance, so there's always Mount Hood and Mount St. Helens there in the Cascades, and as I got into university, I stayed in Washington, went to University of Washington, and started exploring mountains as I studied geology, and I think it's more the, like, once I learned that there's so much information that's captured by landscapes, that's when I got super jazzed about becoming a geologist. And so I studied geology all through my PhD. And like, how lucky are we that the Antarctic ice sheet and Greenland ice sheet are recording climate information for us? Like, we'd be flying blind if we didn't have this. Like, right, we started measuring CO2 on the surface as clever little humans in 1958. And we've kept that up continuously since 1958 at Mauna Loa in Hawaii, a very important observatory. But if we didn't have ice cores, we would have no direct measurement of carbon dioxide before 1958. And
Wow.
so thank goodness for snow in Antarctica. Like, it's just fantastic.
Which, after hearing that, okay, 1958 was a while ago, but after hearing that you're looking at samples from hundreds of thousands of years ago, like, yeah, wow, what an amazing opportunity. Now, you mentioned CO2 emissions multiple times here, and I know on your social media, what is one of the many things that's so great about it is you really explain with your words, but also visually show us the impacts of CO2 in our atmosphere, with your ice samples. For someone like myself, I'm in a 4 seasons climate. I hear that glaciers are melting. That's not in my backyard. That's not my problem. That doesn't directly impact me right now. What do you want people to know about what you're studying, what you're working on, and how it impacts everyone?
I shared that 800,000 year carbon dioxide record from ice cores on TikTok, and people are blown away by it and have all sorts of reactions, up and including we're screwed, which is a fair reaction, and I hope one that people don't stew in too much. But right, when you show 800,000 years of carbon dioxide from Antarctic ice cores, there's variability. There are 8 ice age and warm and cold period cycles over the last 800,000 years because of how Earth's orbit changes around the sun. That's like a known process, and CO2 in that time varied from like 200 parts per million to just under 300. And every time it was sort of within those bounds. And then if you plot today on there, we're up to 420 parts per million in just 150 years. So right, 800,000 years like this, and then 150 years where we've increased it by 50%. And temperatures is climbing up because of that. So what I want people to understand in me showing my social media is like that it's, I guess, the information that we have is very direct, and it's produced by humans, which have flaws and can have biases and have blinders on, where we're just like assuming that this Antarctic air is actual direct air. Like, we work so hard to demonstrate that it is. So I hope that, like, the authenticity of me being like recording when I'm in Antarctica, like, this is ice. I show the process of how we go from drilling to putting it in the sample chamber to extracting the air out to putting it in an instrument. Like, there's no, if only I could do it without cutting away. Like, we're not fudging anything. So like, that's one aspect, and people trusting the information is critical. But like right now, I think we're at a juncture where people need to know what we are doing and what we can do to get out of the bad situation that is caused by rapidly increasing greenhouse gases in the atmosphere, right? Temperatures warming fast, and it's going to warm past some pretty dangerous thresholds in the next couple of decades if we don't transition away from fossil fuels, carbon-based fuels. So that's a challenge, and people see the ice core data and they're like, we're screwed. And that, it's a fair reaction, but my message is climate change is real. it's us scientists. 99.999% agree. Literally, the update to that scientists agree number is like in 80,000 papers that somebody analyzed. It was 99.99%.
Right.
Like climate change is a thing. Like it's very well established. But there's still time to avoid the worst consequences and impact of a warming world. And so I think that's the critical thing right now, is that we need to keep people energized, right? If we can hold their attention, right? There's a lot of things that every individual has to pay attention to, and climate change certainly is not the top one, beyond bills and keeping your family fed and all of that stuff. And keeping our democracies functioning. Like there's a lot of things that are sort of getting in the way of taking the really just putting in the hard work that we need to transition away from fossil fuels. So that's, I guess, sort of getting towards like the biggest challenge in communicating about this stuff. I don't work in the climate solutions space. I know a lot of people that do, and I know the information, but where I try to sit in where I have the most credibility and expertise is like, what is the problem with climate change? And so that's what I try to focus on a bit, but people need that extra, like, okay, what can we do? Because it is scary.
Absolutely. So, with that being said, for someone like yourself who is literally discovering the evidence that climate change is here, it is alive and well, where do you find hope when you're looking forward?
Yeah, I mean, I find hope, and I also am fearful when I watch my 2-year-old daughter, discover the world, and she's discovering the world during a global pandemic, which is interesting. But I think of the numbers that the projections that I've always seen of climate change and of sea level rise. But I think of now, how old she's going to be in 2060, right? Like in 2060, that's going to be the prime of her life. She'll be 40, and hopefully accomplishing great things. So the hope I see is when you actually do start looking at what people are doing at, I guess, more at the grassroots level. Like individuals, there are states that are leading on this, and there are, just in the last few years, legislative action to support adapting infrastructure, right? Like there's a lot of conversations around infrastructure in the United States right now, and there's just a lot of people who get very little attention, who are there talking to the legislators and hopefully working like as funds are allocated to make sure that when we're making these multi-decade investments in infrastructure, we're taking into account how we can make them more resilient to the impacts that we know, right? We've committed to certain impacts, and we want to do a lot of work to avoid those impacts getting worse, but we sort of need to do both things, right? So in the business, we call it adapting to the impacts that are coming, and trying to mitigate the situation so those impacts don't become worst case scenarios. So I interact with that a lot because my wife is actually an expert climate science communicator and climate solutions person. So she sort of pivoted actually from working with paleoclimate archives like ice cores to helping people adapt. So she runs
Wow.
she runs the Minnesota Climate Adaptation Partnership here at the university, and is sort of the first climate science extension educator for the state. So like equipping folks in the agriculture sector with information to plan for the changes that we are fairly confident are coming. And we're doing things like taking the global climate models that we use for the big intergovernmental panel on climate change projections, and we're downscaling them. We're making them finer resolution for the state of Minnesota at like 2 to 3 mile resolution, so that farmers and state agencies who work with farmers have the best information that actually is usable in the context of our state. So there's just a lot of work being done that is just,
Yeah.
it's not flashy. It doesn't get the headlines, right? Like if you saw the movie Don't Look Up, it's the
Mhm.
splashy doomy stuff gets the headlines, but then they sort of just move on to all of the other uh, distractions and shiny objects that are going on at any one time. So yeah, I mean, there is hope, and it's overwhelming the amount of work that we need to do, and it's concerning the number of barriers between us and like top level government leadership on this stuff. There are so many distractions and aspects of that are not working to address the problem. The hopeful thing is that we have a very clearly outlined paths, multiple paths
Right.
to a more sustainable future. The underlying concern is that we are not seeing across the board leadership and genuine engagement in starting down any of those paths. So we're at a really critical juncture where we need to see action across the board, and we need to see it in this decade, right? There's a lot of criticism of the, like, we only have 10 years left, we only have 9 years left, and didn't we say that last decade or something? But like, truly, if we don't start bending the curve, like with COVID, if we don't start doing that, and bending the curve on carbon emissions and thus temperature increase, we're going to face a worst case scenario, right? Like COVID and lockdowns and all of that.
Yeah.
Like, you have to put in all of these measures to mitigate the problem, and actually deal with the problem rather than trying to put band-aids on it.
Your daughter is going to have some pretty great dinner time conversations
It can
with
get a little
you guys. That's very cool and so
Yeah.
inspiring. Wow. Dr.
I think
Peter Neff, it was such a pleasure to have you on Earth Care. I can only imagine how busy you are. So truly thank you for your time. And I can't wait to see what you teach us next on your TikTok.
great. Thanks. I appreciate it. It's great to chat.